Okay, Algebra 2s, here is day 5, okay, unit 11. So the number e and natural logarithm is very similar to what we've already been doing for this unit and last unit, okay? We've already done exponential equations with a numerical base. Now we're going to be doing exponential equations with a letter E base. Well, E is equal to 2.718. They have it as 2.72 because they just rounded it to the nearest hundredth, okay? E is a number, okay? Just like pi is a number. You know, pi is 3.14. E is 2.718. So they are numbers, they're just irrational numbers. And E is found with the pi button. It's also found somewhere else on the calculator, but that's fine. You can do it there, okay? So I started this and had to restart the video, so some of this is written on. But it's asking which one of these is an e to the x, an exponential. Okay, so we already learned that there are such things as exponential growth and exponential decay. And that is all based on two specific things. Okay, so last unit you learned that if it was a growth, then the b value was always greater than 1 and it had a positive exponent. If it was an exponential decay, the b value was between 0 and 1 with a positive exponent, or the b value could have been greater than 1, just like a growth, but then it would have had to have had a negative exponent because you know negative exponents make it the reciprocal of the base, which causes it to be a fraction, okay? So 2.718 is greater than 1. So this is a decay, not a growth. So let's look at these choices. The first choice is a u. You know that that's a parabola or a quadratic equation, okay? So it's an x squared type problem. This is an exponential growth because it's going up as you go to the right. And it has an asymptote, by the way, of y equals 0, right? It's crossing the y-axis here, and it's never going to touch or go below it. This is a decay, an exponential decay, also with an asymptote of y equals 0. And then this is a cubic, 1, 2, 3 roots, end behavior. Remember end behavior and roots? I hope, because your Regents is coming up in a couple months. Okay, so this is a cubic. Okay, so x to the third power. So this, choice 2, is a y equals e to the second because of it being an exponential growth. That's the explanation. I wrote it on each one. I'm just not writing it separately. Okay? All right, so your first equation, population of llamas on a tropical island can be modeled by this equation. Okay, now we have talked about this equation already. The P equals, well, for us we used A. A equals P-E-R-T. So P stands for the principal, E is the number, R is the rate, T is the time. So how many llamas were initially introduced? 500. Okay, now they're saying show the work to this. That would simply be if I had 500 E to the 0.035 times 0. Well, that's going to give me 500 e to the, multiply that, we get 0. 500 times anything to the 0 is 1, so it gives me 500. Okay, so there were 500 llamas. Algebraically determine the number of years for the population to reach 600. So we set 600 equal to the equation we had. I need this exponent and this base to be by themselves. So we divide each side by 500. We know the zeros can cancel. I'm just going to use 6 over 5 equals e raised to that 0.035t, which, by the way, if they ask you for what is this as a percent, move the decimal 1, 2, this is a 3.5% increase, okay, in population. So now I have a base and I have an exponent, and I need to solve this. So we do exactly what we did in the lesson prior to this. We take exponent equals log. We use the base e of 6 over 5. Okay? And then divide both sides. Remember, this is grouped. And I get t equaling. This is where we stopped because I didn't have you using the calculator anymore in class. Whoops. And so you would be able to stop here, but you're at home, so you would be able to use your calculator. Hold on a second. I'm trying to get my calculator out of the drawer. And just so you know also, which is going to be on the next page, log base e. If there's ever an e on a log, then they really use what's called natural log. It already has the e there. If I gave you the word log 7, you know the invisible base is 10. Well, if I ever gave you ln 7, the invisible base would be e. Okay? So I'll show you that on the next page. But let's go ahead and get our final answer to this. So I would set up my calculator with a division bar, and I would use log base e of 6 over 5 and divide that whole thing by 0.035. So I get 5.209, and it asked me to round to the nearest tenth of a year, so 5.2 years. Okay? Now again, on a regions, show the long decimal that you got in the calculator just in case you make any rounding error. Okay, so next page. Just like we were doing y equals 2 to the x, and then we changed that to an inverse so that we could write it as a log, we switched the x and the y. And then we said exponent equals log base 2 of x. Well, the same thing occurs here, okay? So they switch the x and y. X equals e raised to the y. And then they take this and they put it in log form. Y equals log base e of x. So that's this over here, and they're just letting you know if you ever have a log with a base e, it is the same thing as just writing the natural log x. Okay, it means the same exact thing. So without your calculator, determine the following things. Well, if we know the base is really e to the what would equal e? 1. This is just like when you were doing log base 10 of 10 equals 1, because 10 to the 1 equals 10. So same here, if it was an e raised to what would equal 1? 0. E raised to what would equal e to the 5th? 5. This really means ln of e to the 1/2 because of a couple units ago. So e raised to what power would give me e to the 1/2? Well, it's got to be a half, right? So that's all stuff that you've done all last unit. That's why I say this really is a review, okay? It's just it's using the word ln instead of log. So this right here, if you notice, all of a sudden it's getting written differently. So what we're trying to do is we're trying to expand using our laws, okay? The P-man over S that we learned the other day. So just because it says ln doesn't mean anything. You're going to just use ln instead of log. So an exponent is a power. A power means multiply. Multiplication we always put in front. Division means subtraction, so minus. And then the exponent is a power, so power becomes multiplication we put in front. Okay? And now we already said if you have ln e, well that means the base is e. E to the what equals e? 1. So all of this just means times 1. So we get ln x with a 3 in front. So 3 ln x minus 2 times 1, which is 2. And that is choice 2. Okay? So here comes our real world equation problem. A hot liquid is cooling in a room whose temperature is constant. That's that room temp. That's always your asymptote. Okay? And it can be modeled by this. So this right here, if you recall from the last couple of lessons, this is your asymptote. So y equals 67 would be your asymptote if this was graphed. Okay, if something is cooling, it's not going to go any lower than that 67 degrees of the room. Okay. M is the number of minutes. Okay, and of course, E raised to a negative, that's telling you it is also cooling, right? So what is the initial temperature? The initial temperature is always your y-intercept. So we would do 101 E raised to the negative 0.03 times 0 plus the 67. So we're just subbing in a 0 for M. Well, all of this equals 0, and E to the 0 is 1, and 100 times 1, 101 times 1 is 101 plus 67. So the initial temperature is 168. So it would start at 168, and it would continue to cool until it hit room temperature over time and degrees Fahrenheit for temperature. Okay, so how would you interpret this? Well, this is the same exact problem we did a couple of days ago. This is your minutes, and this is your temperature in degrees Fahrenheit. So what does this mean? It means after 60 minutes, or after 1 hour, it has cooled to 83.7 degrees Fahrenheit. Okay, using natural log, determine when it will reach 100. So we want it to get to 100 from 101 E to the negative 0.03 time, or, well, they had minutes, plus 67. So how do I solve this? Minus the 67 from both sides. So that gives me 33 equals 101 E raised to the negative 0.03 M. And you subtract. I cannot do anything unless this exponent and base are by itself, so divide by 101. Oops. Okay, that cancels. So now I have exponent equals log. Negative 0.03 M equals log E, but we know log E really means ln with a base E, of 33 over 101. Don't worry about putting that in the calculator, just like we didn't in class. Divide to get M by itself, and then type that into your calculator. So, in our calculator, we set up a fraction, and we use ln, and if you notice, ln is right here next to log. So, control ln, and then notice it doesn't give you a base, because it knows the base is E. And then just put your 33 over 101, and then divide by 0.03 as a negative, and we get 37.28709, blah, 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 said to the nearest tenth. So after 37.3 minutes, it has become 100 degrees, okay? Average, the average temperature. So that means you want to find after 10 minutes what the formula would give you, and after 30 minutes, okay? So if you recall, we did this last unit we did the change in y, which is your function, over the change in x. Okay, so we need to plug in to the formula a 10, and then we need to plug into the formula a 100. So you could either put this in the graphing part of the calculator, go to the table and look up those numbers, or just use straight substitution. Okay, so 101 E, if you use the E to the X button, it sets it up for you right away. You can go ahead and put that in there. Okay, times 10, arrow to the right, and put your plus 67. Okay, so that's going to give us 141.8226 and so on, minus. Now, I'm just going to go up and copy that and change this to 30 degrees, or 30 minutes. And I actually just did that in reverse, didn't I? So this one is the 108.0635, and this is 141.8226 over 20. Okay? So I'm going to go ahead and use my calculator, take the answer to the 30, and subtract the answer to the 10, and then divide that, negative 33.7591, and so on, by 20. And I get a change, average rate of change, as a negative 1.6879552, and so on. It asks for the nearest tenth. So it is negative 1.7 degrees. So that's basically saying it's going down by 1.7 degrees per minute. Okay? All right, so pause this, rewind it, do whatever you need. And then don't forget, this is review, so apply all of this knowledge and what you've gotten from all days 1, 2, 3, 4, plus last unit, whoops, and do the next page, okay, the fluency, because that is what your homework also included, okay? So we did this lesson, and now you're going to do this fluency as well. Okay, so your entire packet should be done up to page 20. Okay? Have a great day.